it's important to understand exactly what these are. And so understand that a ratio is just comparing two things by division. And if I said 3 over 2x there, I'm comparing the 3 to the 2x, so I'm comparing two things by division. That would be a ratio. Now, a proportion is when we say, okay, take that 3 over 2x, that's going to be equal to 5 over x plus 1. When you say that two ratios are equal, then you have a proportion. Now, we've done proportions before. As we solve proportions, we're going to cross multiply. And so you'll see that a lot today. What we're going to do is we're just going to multiply the diagonals together. So 2x times 5. And then I'm going to multiply, set that equal to the other diagonal. So in a proportion, if you multiply the diagonals, they are equal to each other. What that allows me to do then is to condense this down. 2x times 5 is going to be 10x. 3 times x, and 3 times 1, that's going to be 3x plus 3. You'll want to identify today what type of problem you have. As you look at this, this problem just has x's on both sides. Because it just has x, since it has x's on both sides, I'm just going to combine those x's together. So subtract 3x, 7x equals 3, solve by dividing by 7. X is 3/7. So I'm able to get it down to a form that I can solve easier by going through and cross multiplying, so multiplying the diagonals. Then I see that there are just x's in the problems, so I can just solve for x, and I'm done. Now, another example could look something like this, where I have 5x over x plus 7, and that's equal to x over x minus 1. Now, as I look at this problem, again, I'm going to multiply the diagonals. So 5x times x minus 1 equals, and then x times x plus 7. So take the 5x into both of them. That's 5x squared minus 5x. Take the x into both of them. That's x squared plus 7x. Now, as I look at it, now I see a problem where I have both x squareds and x's. When you have x squareds and x's, our only two methods of solving them are to factor or use the quadratic formula. No matter which one of those methods I'm going to use, it has to be equal to 0. So I have to get this equal to 0. I'm going to subtract x squared from here, and I'm going to subtract 7x from here. What that'll do is that'll cancel out this right side so that it equals 0. But now if I subtract x squared from here, I have to subtract x squared from here. If I subtract 7x from here, I have to subtract it from the left side as well. And so on this side, I'd have 4x squared minus 12x. A lot of mistakes right here. Make sure you take care of that. Negative 5x minus 7 more x's. That's going to be negative 12x. The other common mistake that happens here is people will start trying to factor this right away. Remember, don't try to factor until you've pulled out what they have in common. So you got to actually factor out what they have in common first before you can do anything else. And so I look at this. 4 and 12. Well, they both have a 4 in common, and they both have an x in common. So I'm actually going to pull out the 4x. 4 divided by 4 is 1, and if I take away an x, I still have an x left. 12 divided by 4 is 3, and if I take away an x, I no longer have an x there, so I get this. Now, if 4x times x minus 3 equals 0, either the 4x has to equal 0, or the x minus 3 has to equal 0. That's by the zero product property. If these two things, if I'm multiplying two things together and equaling 0, then either the 4x has to equal 0, or the x minus 3 has to equal 0. Divide by 4, divide by 4. If 4x equals 0, then x would be 0. Add 3, add 3. If x minus 3 equals 0, then x equals 3. And those end up being my solutions. Remember that when they ask to solve, we want to find the solutions that work for x. Here there are two solutions. Could be 0, could be 3. Here there's just one solution. It's the 3/7. And so depending on the problem, you could have one solution, two solutions, maybe three solutions, any number of solutions depending on the problem. Let's look at one more, because there's one more situation I want to talk about. Let's look at 6 over x plus 2 equals x plus 1 over x. The first step does not change. 6 times x is equal to x plus 2 times x plus 1. Now think back to when we did these. This is just a binomial times binomial, so I'm going to FOIL x times x. That's going to be x squared. X times 1 is 1x. That's the outside. The inside is 2x. And finally, the last is just 2. Condense it down. 6x equals x squared plus 3x plus 2. I see that there's x squareds and x's, so I want to get one side equal to 0. So I cancel out the 6x by subtracting 6x, and I get x squared minus 3x plus 2. Again, the very first step, look to see if there's anything that all three of these have in common. So 1, negative 3, and 2. Nope, nothing there. X squared, x, nothing. Nope, nothing there. If they don't have anything in common, then you can go to factor. So I go to factor here, and I get that I have x minus 2, x minus 1. X times x is x squared. I know the only way to get 2 is to take 2 times 1. I know that the signs have to be the same because this is positive. And so I look at it, 2 times 1, does that add up to 3? 2 plus 1 is 3. I'm good to go there. So I know that x minus 2 times x minus 1 equals 0. Notice I have not answered anything yet, though. I have to actually find out what x would equal. If x minus 2 times x minus 1 equals 0, then either x minus 2 equals 0 or x minus 1 equals 0. Well, add 2, add 1, add 1. That means my answers are 2 or 1. And so those are my two answers. And that is how you solve ratios and proportions. Okay, and just to end things off here, I do want to end with a little bit of a joke here, and it's, why can't you take a picture of a man with a wooden leg? Because you can't take pictures with a wooden leg. Guys, eat some bacon. Have a great night. We will talk to you later.